Next question, test the consistency and solve x plus 2y plus 3z is equals to 14, 4x plus 5y plus 7z is equals to 35 and 3x plus 3y plus 4z is equals to 21. So to test consistency, first we need to check the given system is consistent or inconsistent. If it is consistent, we need to find the solution of the equations. For that, first we need to write the given system of equation in matrix form. What is that matrix form? Ax is equals to b. So first write matrix of coefficient values. X coefficient 1, y coefficient 2, z coefficient 3. In equation number 2, 4, 5, 7. 4, 5, 7. Next, in equation number 3, 3, 3, 4. Next, into next write a matrix of unknown values x, y, z. X, y, z is equals to. Next write a matrix of constant values 14, 35, 21. So this is the matrix form. Next, using this matrix form, next write augmented matrix. Augmented matrix. First row 1, 2, 3, 14. Second row 4, 5, 7, 35. Third row 3, 3, 4, 21. Now we should apply row reduced to echelon form to find rank of augmented matrix. So now apply row transformation. So here leading element is already 1, therefore second row first element, third row first element we should make it 0. So for that apply a row transformation. R2 changes to, so here R2 is 4 minus 4 times of R1, so that time this value goes to 0. Next R3 changes to R3 minus 3 times of R1, 3 times of R1. Now apply. So we are not changing the first row, therefore first row keep it as it is 1, 2, 3, 14. Next we are changing the second row. So now apply R2 is 4, so 4 minus 4 times of R1 minus 4 times of R1 is 1. Sorry, 4 minus 4 times of 1, that is 0. Next 5 minus 4 times of 2, 4 times of 2, minus 3. Next 7 minus 4 times of 3, minus 5. Next 35 minus 4 times of 14, minus 21. Next R3, 3 minus 3 times of R1 is 1, 0. Next 3 minus 3 times of R1 is 2, minus 3. Next 4 minus 3 times of 3, minus 5. And last 21 minus 3 times of 14, minus 21. Next third row second element we should make it 0, therefore apply R3 changes to R3 minus R2. So that time this value directly goes to 0. We are not changing R1 and R2, so keep it as it is. R1 1, 2, 3, 14. R2 0 minus 3 minus 5 minus 21. Next 0 minus 0 is 0. Next R3 is minus 3 minus 3 minus 3 minus R2 is minus 3 minus of minus 3. So 0. So write 0. Next R3 minus 5 minus 5 minus of minus 5. Again 0. Next minus 21 minus 21 minus of minus 21. Again this also directly goes to 0. Now we reduced in echelon form, but here only two non-zero rows are there. Therefore rank of augmented matrix is 2 because two non-zero rows are available. Next rank of A. This rank of A also directly goes to 2 because again here two non-zero rows. Therefore here rank of augmented matrix is equals to rank of A. Therefore the system is consistent. Therefore the system is consistent. Now rank of augmented matrix is 2. Rank of A is also 2, but number of unknowns, how many number of unknowns are there? 3. Correct? X, Y, Z. 3. Therefore what we are getting here? Rank of augmented matrix is equals to rank of A matrix is less than n. That is 2 rank of augmented matrix, rank of A is also 2, which is less than what here? 3. Therefore the given system has infinite solutions. Now to get that infinite solution, first this augmented matrix we need to write in equation form. Therefore first one 1, 2, 3, 14 is there. How we can write in equation form? X plus 2y plus 3z is equals to 14. Next minus 3 minus 5 minus 21 can be written as what? Minus 3y minus 5z is equals to minus 21. This I am going to call equation number 1 and this I am going to call equation number 2. Now to get the infinite solution, what we need to do, we should consider let this z as another value. That is we need to consider z is equals to k be an arbitrary. Next step, substitute this z is equals to k in equation number 2. In equation number 2 to get the y value. Therefore equation 2 becomes minus 3y minus 5z is equals to minus 21. Minus 3y minus 5z means how much? K is equals to minus 21. Therefore minus 3y is equals to minus 21. Shift minus 5k to right hand side, it becomes plus 5k. Therefore y becomes minus 21 plus 5k divided by minus 3. So this can be written as y is equals to, write it separately, minus 21 divided by minus 3 plus 5k divided by minus 3. Cancel 7. Therefore y is equals to, minus divided by minus is plus, therefore 7 plus into minus is minus 5k divided by 3. So this is which value? Y value. After getting y value, next put z, that is k, and y value, that is 7 minus 5k divided by 3 in equation number 1. So what is that equation number 1? X plus 2y plus 3z is equals to 14. Substitute x plus 2 into y. Y is 7 minus 5k divided by 3 plus 3 into z is k is equals to 14. Open the bracket. X plus 2 into 7, 14, minus 2 into 5, 10k divided by 3 plus 3k is equals to 14. We need y value, we need x value, therefore shift these values to right hand side. Therefore x is equals to, already in the right hand side 14 is there, keep it as it is. This 14 becomes minus 14, plus 14 becomes minus 14, minus 10k divided by 3 becomes plus 10k divided by 3, plus 3k becomes what here? Minus 3k. That time plus 14 and minus 14 get cancelled. You can take the LCM here. Therefore x is equals to, remaining is 10k divided by 3 minus 3k. If I take the LCM becomes 3, multiply by 1, multiply by 3. Therefore it is 10k minus 3 into 3 is 9k. Therefore x value becomes 10k minus 9k is what? K divided by 3. So this is the solution. Next question, investigate the values of lambda and mu so that the equation x plus y plus z is equals to 6, x plus 2y plus 3z is equals to 10, x plus 2y plus lambda z is equals to mu may have no solution, unique solution, and infinite solution. This means here we need to investigate for which value of lambda and for which value of mu we are getting no solution, unique solution, and infinite solution. So as usual, first the given equation we need to write in terms of matrix form, that is ax is equals to b. So take the coefficient x, y, z coefficient is 1 1 1, here 1 2 3, and last one 1 2 lambda, 1 2 lambda. Next into, next write a matrix of unknown values x y z, x y z. Next is equals to, next write matrix of constant values 6 10 mu, 6 10 mu. Next write augmented matrix, transform to 1 1 1 1 2 3 1 2 lambda. So next write the matrix of constant values 6 10 and next mu. Now we should apply row reduced to echelon form to find out rank of augmented matrix. So now apply. So here leading entry is already 1. We should make second row first element, third row first element 0. So apply row transformation. We are changing the second row. So R2 changes to R2 minus R1. Next R3 changes to R3 minus again R1. Therefore first row we are not changing, keep it as it is 1 1 1 6. Next R2 minus R1, 1 minus 1 is 0. Next 2 minus 1 is 1, 3 minus 1 is 2. Next 10 minus 6 is how much here? 4. Correct. Next R3 minus R1, 1 minus 1 0, 2 minus 1 1, lambda minus 1, lambda minus 1. Next mu minus 6. So right here mu minus 6. Next now third row, this is second element, we should make it 0. So for that apply the row transformation. R3 changes to R3 minus R2. Therefore first and second rows we are not changing, so keep it as it is 1 1 1. Next 6 0 1 2 4, 0 minus 0 0, 1 minus 1, R3 minus R2, 1 minus 1 0. Next lambda minus 1, lambda minus 1 minus of 2 means lambda minus 3 we will get, lambda minus 3. Similarly mu minus 6 minus 4 means mu minus 6 minus 4 is minus 10, minus 10. Now we reduced in echelon form. Here total 3 non-zero rows are there. Therefore rank of augmented matrix is 3. Rank of coefficient matrix, that is rank of A, is also 3. Correct. Therefore rank of augmented matrix is equals to rank of coefficient matrix. We are getting 3. Therefore system is consistent. Therefore system is consistent. Now we have to verify 3 observations. Correct. We need to, after that we need to verify these 3 observations. Unless we don't know the value of lambda and the value of mu, we cannot specify these 3 observations. Therefore now if we take, if lambda is equals to 3 and this mu value is not equals to 10, then system is inconsistent. If system is inconsistent, then we have to write there is a no solutions. Then there is no solutions. See, lambda is equals to 3. Here if I take in this place 3 minus 3 goes to how much here? 0. Correct. So that time rank of this coefficient matrix directly goes to 2, and rank of this augmented matrix is how much here? 3. Correct. Because we are taking lambda value is 3, but we are not taking mu value is 10. We are taking some other values, not 10. Correct. So that time rank of augmented matrix becomes 3, and rank of this coefficient matrix, that is A, becomes 2. So that time 3 is not equals to 2 means it has no solutions. Correct. Next, second one, if lambda value is not equals to 3 and mu value is not equals to 10, we get unique solution. We get unique solution, right? So in place here, if you not take lambda is not equals to 3, means some other values if you take here, so that time rank of this coefficient matrix becomes 3. If you take some other values for mu, not 10, some other values, so that time rank of this augmented matrix also becomes 3. So that time rank of A is equals to rank of B, then system is consistent. If it is consistent, then what we conclude, the unique solution, means that system has unique solution. Similarly, third one, if lambda value if we take 3 and mu value if we take 10, then we get infinite solutions, correct? See here, if we take lambda is equals to 3, 3 minus 3 becomes 0, so that time rank of this coefficient matrix becomes 2, correct? Similarly, mu value if we take 10, so 10 minus 10 is 0, so that time this entire row becomes 0, that time rank of this augmented matrix also becomes 2. So rank of augmented matrix 2 and rank of coefficient matrix is also 2, but n value means how many n values here? 3. There are 3 unknowns, so that time 2 is equals to 2, which is less than 3, correct? Third condition, when we get the infinite solution, rank of augmented matrix is equals to rank of coefficient matrix, which is less than n, then only we will get the infinite solution. So if you take lambda is equals to 3, mu is equals to 10, that time this complete row becomes 0, so that time rank of this coefficient matrix becomes 2, rank of this augmented matrix also becomes 2, but we have 3 unknowns, n becomes what here? 3. So that time we will get which type of solution here? Infinite solution. Therefore, please remember, for which values of lambda you will get no solution? If lambda is equals to 3 and mu value is not equals to 10. If lambda is not equals to 3, mu is also not equals to 10, so that time we will get unique solution. If lambda is equals to 3 and mu is equals to 10, that time we will get what? Infinite solution.